There they are. Yes. A lot of people I recognize there. So it's incredibly important to me personally, and also to all of us at NASA, that the universe belongs to everyone. And we are thrilled to share this day with fans everywhere around the world. We'll say hello to some more later in our broadcast. So now it's time to start the main event. What you'll see over the next hour will be a collection of images newly processed by the Webb science team. Only a tiny handful of experts have seen the images so far, and I can tell you that we have been so excited to unwrap them for everyone. We will be releasing each image in turn in real time. As soon as you see it on this broadcast, it will be available for download on the internet. On the screen below, you can see a timeline showing where we are in the show and what's coming up next. And by the end of the show, all 5 images will be available to everyone. So hopefully you can tell I'm excited. Okay, so let's do this. Okay, we're going to release the first image right here at NASA Goddard Space Flight Center, Maryland, and we're just outside of Washington, D.C. NASA Goddard is home to the project office of the Webb Telescope, and the observatory portion of the telescope, the mirrors and the science instruments, were integrated and tested here before launch. So for many of us, including myself, seeing Webb come together bit by bit right in front of our eyes was an emotional and very inspiring experience. So it's kind of like a part of us was out there with Webb right now. A million miles away, part of our hopes and dreams are out there. So
ones we're seeing as they looked about the time the sun and the earth formed. And then behind the cluster, we have the gravity of the cluster is distorting and warping our view of what's behind. And so there are these galaxies that look stretched and pulled, kind of like they've been magnified because they've been magnified by the gravity of the cluster, just like Einstein said they would. And, you know, it's really, there's so much detail here. We're seeing these galaxies in a way that we've never been able to see before. There's just a sharpness and a clarity we've never had. And so we can look at, if we zoom in on this image, and I encourage you as you grab this image at home, like zoom in. You can, you know, really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars forming, popping up just like popcorn. And then we also see in the background of this image, kind of littered like jewels all over the back of the image are these faint red galaxies. Now, that was what we built the telescope to do. The most distant of those are billions of years. We're seeing as they looked more than 13 billion years ago. And so galaxies like that one right there, this little red guy, you're like, okay, yep, what is that? Well, Webb got spectra to figure out what those galaxies are made of, and this is that one. We're seeing as it looked 13.1 billion years in the past, less than a billion years after the Big Bang, and we're seeing the elements of oxygen and hydrogen as well as neon. You know, this is how the oxygen in our bodies was made in stars, in galaxies, and we're seeing that process get started.
Yeah, I want to give this a little bit of context. So this is now the farthest away galaxy that we have this sort of detailed information about.
That we know what it's made of.
We know what it's made of.
Yes.
And this was not a long exposure for Webb.
No, the previous record holder, right, the Hubble Extreme Deep Field, was 2 weeks of continuous work with Hubble, and it was just imaging. With Webb, we took that image before breakfast. The amazing thing about Webb is the speed at which we can churn out discoveries. So everything that you're going to see here in this broadcast is a week, and we're going to be doing discoveries like this every week.
That is absolutely incredible, Jane. So thank you so much for joining us. It's been an honor to be working with you. Congratulations on all your hard work.
Thank you. It's so wonderful to see it pay off.
So thank you, and I'll see you later on today, I hope. So
yes.
Enjoy the day.
Thank you.
Right. So from distant galaxies, we now turn our eye to something a bit closer. It's a planet, but not one in our solar system. Remember that Earth and its sibling planets aren't the only show in the universe. When scientists and engineers started developing JWST, the search for exoplanets wasn't even part of the plan. That's changed. Exploring exoplanets is now a major component of the mission and the subject of our second big reveal of the day. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space Agency in Montreal. So again, bonjour. I guess we're having a little.
Okay, I'm Nicole Malone, and I'm here to tell you.
Sorry for the brief pause there. We're now going over to Canada. Okay. Yep, we're all ready. Yeah. Okay, I apologize. We're having some trouble with the signal from Canada, but luckily for us, we have an exoplanet expert right here, just in case that happened. So this is Nicole Colon, and she's an exoplanet scientist at NASA, and we're going to talk about this amazing new result from a very hot planet, I understand about 1,000 light years away.
That's right. The exoplanet is named WASP 96b, and it is this hot, gaseous, giant, puffy planet that it is about 1,000 light years away. So that's why today's release is so exciting, because it teases at what that is going to do for such a distant.
Absolutely. So talk us through what this discovery is and why this is so significant.
Mm-hmm. Well, this reveal that you're going to see is going to show the first spectrum of an exoplanet as taken from the Webb telescope. And this is exciting because it covers infrared wavelengths of light that we have not had access to before. So we've been able to use other telescopes to explore exoplanet atmospheres in the infrared, but not to this level of detail. And this is just one sliver of data that Webb is providing us using the nearest instrument specifically.
And there's something about infrared that is actually particularly good for the spectrum. So in this case, what we're doing is we're actually going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum. So I believe we have that image, if we can put that up.
Okay, yes, I believe we're revealing the spectrum right here. So we now have our spectrum, and this is exactly what you're seeing. As you just described with spectroscopy, what we did was we observed a transit of an exoplanet. We observed the planet as it passed in front of the star. Now, mind you, this is not a direct image. This is an indirect image. So we've seen the effect of what happens when the planet and its atmosphere passes in front of the star. The starlight filters through the atmosphere, and then you can break that down into wavelengths of light, and you get a bunch of what looks like bumps and wiggles to some people, but it's actually full of information content. So you're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
So we have the spectrum up here. Is there anything you'd like to highlight particularly?
Yeah, absolutely. So we have several features marked here. So I call them features. They're these, what I just referred to as bumps and wiggles. But what you're seeing here is a telltale signature, the chemical fingerprint of water vapor in these atmospheres, in the atmosphere of this specific exoplanet. And the other thing we can tell actually is that there's evidence of clouds and hazes because the water features are not quite as large as we predicted. So we can take that and infer that there are presence of clouds and hazes.
Right. Now, one thing that we really want to make sure people understand is with this particular planet, this is a hot world. It's actually closer to its star than Mercury is to our sun. Mm-hmm. And so we're not looking at liquid water here, but we're looking instead at sort of steam, water vapor.
Yes, this is an exoplanet. It's about the size of Jupiter, about half the mass of Jupiter. It orbits around a sun-like star, but it does it every about 3.5 days. Right. So it's extremely hot, extremely close in, nothing like our solar system planets. But that's okay, because what we're seeing is, again, the first exoplanet data from Webb, and this is just the beginning. We're going to start pushing down to further smaller planets and being able to take measurements just like this with the nearest instrument that was built by the Canadian Space Agency, but also there's three other science instruments that will add to our knowledge in the infrared, as well as direct imaging modes along with the transit method. So there's a lot more to come.
I guess one thing we should mention is not only are we going to be looking at planets that are more like the Earth in the future, but we'll also be looking at planets in our own solar system.
Absolutely, yes. We're going to have exciting data from planets in our solar system, from Mars outward, as well as asteroids and comets. So stay tuned for a lot more to come.
Thank you so much, Nicole. Thank you so much for telling us about the spectrum, and I'll be seeing you later on today. So we have 3 more big image reveals, and with that, new and more exciting science. But first, let's take a look back at the journey that brought us to this moment. Celebrations like this one are only possible with years of hard work from a cast of thousands. When a new mission is being built, even the most enthusiastic space fans only get to see dramatic moments in its life cycle, the news and images